Let's do another example of solving a system of equations by substitution. And if you're also wondering, like, when would you even use substitution? Like, I wouldn't use it all the time, but I think when I would use it is when one of the variables only had a coefficient that only had one right here. So see how this x has a 6 and this x has a 7. Or this one right here, okay, like has a 1 as well. That's only when I would do it right here, okay? Because you just want to be able to get a variable and isolate it. So I think what would make this whole thing easiest is if I took the second equation and I divided both sides by -1. Because by doing that, I get y equals -4 minus 7x, which that means now I know what y equals, okay? And so I'm just going to highlight this there. Y equals -4 minus 7. Which means if I go up here to this equation, what does this y equal? Well, this y is -4 minus 7x. So let's go ahead and do this equation over again right here then, okay? So let's just 6x minus, now instead of doing y, I'm going to put what y is. Y is -4 minus 7x. Oh. Equals -9. And notice what I've done once again is I've eliminated the y's, and so now I could solve for x. So drop down my 6x, and now I can multiply. Negative times a negative, it's a +4. Negative times a negative, that's a +7x. I can combine those guys. I get 13x plus 4 equals -9. Subtract my 4 on both sides. And I'm going to get x equals -1, right? Sweet. So again, that is my x value, but now what is my y value? Well, again, look. Oh, there it is. So what is y? Y is -4 minus 7 times -1. That equals y. So that's -4, and that's plus 7 equals y, which is just 4, right? So that's going to be 4. Sweet. So that is our solution, -1, 4.